Hello everyone, Mr. B here once again for our video series on fractions. This is video 6. We're going to simplify fractions now. So what's the definition of a fully simplified fraction? It's when there are no common factors other than 1 between the numerator and denominator. And there's some other ways to describe a fully simplified fraction. Some people call it the simplest rational form, or the fraction is reduced to lowest terms, things like that. Okay, let's get into an example here. We're going to simplify the fraction 12/18. So the quickest, to do it in the beginning here, let's get the prime factorizations for the numerator and denominator. So I've done that here. 12 is 2 times 2 times 3, and 18 is 2 times 3 times 3. I can rearrange things here and write this as 2 over 2 times 3 over 3. That takes care of 1, 2, and 1, 3 in the top, and a 2 and a 3 in the bottom, and that leaves what? I've got an extra 2 in the top and an extra 3 in the bottom. But notice that the 2 over 2 is 1, and 3 over 3 is 1. So we're multiplying 2/3 by 1 twice. That means that the final answer is 2/3. That's the fully simplified form of 12/18. This may not be the quickest way to do it, but I wanted you to see that the basic underlying principle here is that these common factors between the top and the bottom create ones. Let's tie in a previous video. Remember when we got the greatest common factor? We did it for 12 and 18, and we found that it was 6. So notice that 12 can be written as 2 times 6, and 18 is 3 times 6. 2 and 3, those are prime numbers. And the 6's, what if we break this up like this? This is like 2/3 times 6 over 6, where the 6's are the greatest common factors. Well, 6 over 6, ta-da, that's 1. And we get 2/3 again, just like we got before. The GCF, the greatest common factor, lets us simplify a fraction in one step, because you can pull out the greatest common factor. It's the same in the top and the bottom. They cancel, leaving the simplified numerator and denominator. It may not be the easiest way, and it's usually slower because you have to do the extra work to find out what the GCF is. Sometimes you can just look at the numbers and, oh, I know the GCF is 6. And so you would just divide 12 by 6 and 18 by 6 and get 2/3. Okay, well, let's look at some more examples. I think the simplest way to simplify, the quickest way to simplify, is to just get the prime factor expansions, these prime factorizations of the numerator and denominator, and then cancel the common factors that are in the top and the bottom, the numerator and denominator. So we see here, we've got 2's top and bottom. We have 3's top and bottom. Those cancel. That leaves 2/3. Easy, right? Okay, let's do another one. This is the same one, but I'm going to do it in a slightly different way. I'm just going to look at the fraction and think about, okay, this is a notational thing. Instead of writing the prime factor expansions, the prime factorizations, I'm going to think about what divides into the numerator and denominator together. So certainly they're both even here. So let's divide 2 into the numerator. That's 6. 2 into the denominator. That leaves 9. So now we're down to 6/9. I can write that. We have 6/9. But there's still a common factor, right, of 3. So I probably wouldn't even have written this. I would have kept going. I would have said, okay, 6 is divisible by 3. That's 2. 9 is divisible by 3. That goes in 3 times. And I would have wrote, oh, you know, I can't find any other common factors for 2 and 3 other than 1. So the answer is 2/3. Another way to do this would have been maybe, okay, we've got 2/18. I see that 6 goes into both of these numbers, right? So 6 goes into 12/2, 6 goes into 18/3, and we're already done because 6 was the GCF. Okay, let's see an example where the numerator and denominator are larger. How about this? So remember, we had these in a previous video, 360 and 840. So I've got the prime factorizations for those numbers. And let's just do it by canceling the common things in the top and the bottom. We see, okay, we got a pair of 2s top and bottom, another pair, a pair of 3s. We see that there's 5s top and bottom. What's left? 3/7. That's the simplified version of 360 divided by 840. Okay, let's do it another way. Looking at this fraction, we could say, well, we've got 0 as the first digit of both the numerator and the denominator. I'm just going to cross those zeros out. This is like dividing by what? By 10. If you divide 360 by 10 and 840 by 10, you get 36 over 84. Now what? Well, let me write that as a separate fraction. 36 over 84. Okay. Let's say my brain isn't really at full power and I see, oh, they're even. I can divide by 2. Easy, right? Just divide both by 2. Half of 36 is 18. Half of 84 is 42. Oh, they're still even. Okay, divide by 2 again. That gives 9. 2 goes 21. Okay, it's not 2 anymore, divisible by 2, but it's divisible by 3. Okay, so divide by 3. 9 divided by 3 is 3. 21 divided by 3 is 7. Well, those are prime numbers. There's no common factor. 3/7. Done. Okay. I think there's one more example. 30x to the 5th over 24x to the 3rd. How might we deal with this one? Well, let's worry about the numbers first. So what's a common factor between 30 and 24? Certainly 2, right? So let's divide the top and the bottom by 2. That'll leave 15 and 12. Is there a common factor for 15 and 12? Sure, 3. 3 goes into 15, 5. 3 goes into 12, 4. And there's no common factor between 5 and 4. So we're done with the number part of it. How about the x variable? We've got 5 x's on the top, 3 on the bottom. So all 3 x's on the bottom will knock out 3 of the ones on the top. So we have 5. If we subtract 3 from that, we have 2. So our final result is 5x squared over 4. All right, that's it. That's the simplified fraction. Okay, that's it for this video. We'll see you in the next one.